The braking system enables the vehicle to decelerate as quickly as possible while preventing the wheels from locking. It mainly consists of disc brakes, an ABS unit, a master brake cylinder, and a brake booster. The brake booster amplifies the force exerted on the pedal. It comprises two separate chambers subjected to the vacuum generated by the engine or a vacuum pump. The force exerted on the brake pedal is amplified by the difference in air pressure in the working chamber, which acts on a membrane piston. At rest, both chambers are connected. Pressing the brake pedal closes the connecting channel and compresses a reaction disc, which opens the passage to atmospheric air. The resulting pressure difference moves the diaphragm piston until the atmospheric air passage is blocked. By increasing the force with which the pedal is depressed, the phenomenon is repeated until maximum differential air pressure is reached. When the pedal is released, the communicating passage between the two chambers opens, allowing pressure from the working chamber to flow into the vacuum chamber. The master brake cylinder pressurizes both hydraulic brake circuits through the movement of two independent pistons. The brake fluid flows internally to each piston through an after flow valve. These valves are closed during the braking phase and open when not in use. The opening allows the volume of brake fluid to be equalized due to temperature changes or lining wear. The brake fluid flows through the brake lines to the ABS unit and from there to the brake calipers. The pressure in the system moves the pistons of the brake calipers. The force exerted acts on the brake pads, which break the rotation of the disc by friction. One speed sensor per wheel sends a signal to the ABS control unit. This signal can be sinusoidal or rectangular. The ABS control unit compares the frequency of the signals received, taking into account the actual speed of the vehicle. If the frequency of the signals changes when one or more wheels are blocked, the ABS unit will ensure that further blocking is prevented. An electric pump is switched on for this purpose. This drives pump elements that generate the pressure in the hydraulic circuit. Inlet and exhaust solenoid valves control the maintenance, release, and buildup of braking pressure on locked wheels. Schematically, the hydraulic circuit is pressurized when the brake pedal is depressed. If one or more wheels lock, the ABS pump is switched on. The inlet solenoid valve maintains pressure, preventing pressure buildup on the locked wheel. An exhaust solenoid valve will release the pressure until the wheel rotates again. Once the wheel is turning, the exhaust solenoid valve closes and the inlet solenoid valve opens, gradually releasing the braking pressure generated by the ABS pump. This process is repeated until the vehicle comes to a standstill or the brake pedal is released.